Tobias, there's a lot of conversation about dry fiber right now, and I know it's in the early adoption phase for a lot of manufacturers. But from a kind of engineering point of view, what does dry fiber forming actually mean, and how is it different from other types of forming like pulp molding?
Well, Dean, the difference is already in the name because the name says it's dry, the fiber. When you compare to traditional wet pulp molding, you have the fibers divided in a pulp solution, like 2% of fibers, and then you suck them out as a form part, as a packaging form part, and then you have to get rid of the water. You have to press the water out. You have to dry it with heat, and that's not happening in dry fiber at all. In
Mm.
dry fiber, we have the fibers, almost at air humidity level, and we just press them in a form. And by pressing and applying pressure and heat, we form the form parts and have no water involved in the process that we have to dry. So the energy consumption and also the process time are much faster for dry fiber processing than for wet fiber, and that's a big advantage for the industry because it's always about output and process efficiency, and this is what dry fiber gives to the customers.
What do you mean by faster? What element is faster and why?
Well, the forming process itself is faster. You don't have to wait for the time until the fibers are applied to the vacuum tool, and you don't have the drying steps afterwards in the process. You just put a blank onto the machine, so to say. You form it, and then you're finished with the part in only some seconds. So much closer to thermoforming from the processing time as to wet fiber.
So is it more closer to thermoforming speeds, would you say?
Yes, it is. But to be
Mm.
honest, of course, the process have some drawbacks in the efficiency and in the process time. Um, a really elaborated thermoforming process is faster than dry fiber at present maturity level. But yes, as said, we are much closer to thermoforming. We can almost keep up the pace with thermoforming in terms of productivity. So the machines we use can go up to 15, 18 cycles per minute, depending on the part design, of course. With a multi-layer setup on the tools, you can reach an output of 10 to 30 million a year with the actual designed dry fiber line. And this really meets, from our perspective, the output of thermoforming lines and also the output, of course, of startup scenarios, because I don't think customers will step directly into billions of numbers of produced form parts in dry fiber. They will ramp up product by product and market by market, and this is exactly what our dry fiber lead line is addressed to.